Assalamualaikum and hi to all the students. Now I'm going to deliver my lecture on Laplace transform, which is this is a continuation from the previous lecture. And in this video, I will explain about the definition and notation, Laplace transform for unit step function, second shifting property, and the last one is writing function of t in the form of unit step function. Okay, before we start, I just want to let you know that this topic is quite important because it is useful to model the electrical device in engineering on and off. That's why we use 0 and 1. Okay, for unit step function, I will use notation U. However, some other books they prefer to use a H instead of U. H refer to the Heaviside function. Okay, now a unit step function of t minus a equals to 0 if t is between 0 to a and equals to 1 if t is greater than a. Okay, this is the graph to represent this piecewise function. Okay, if t greater than a, y equals to 1. Here, this is a. If the t greater than a, this is a, y is always 1. And if t is between 0 to a, this part, y is 0. Here we can see y is 0. Now, look at example 3.3.1. Okay, f of t equals u of t minus 2, and we construct the piecewise function, which is we know that a here is 2. So we have 2 here, and if t greater than 2, y is 1. If t less than 2, y is 0. So how the graph looks like? A here is 2. If t greater than 2, y is 1. If t less than 2, y is 0. Okay, the second example is u of t minus 3 minus u of t minus 6. Here we can see that you can have 1, and this is the third one, and the second one is in the middle of 1 and third. So the piecewise function is 3. You can see that 3, 6 here. So if t less than 3 equals to 0, if t greater or equals 6 equals to 0, and the t between 3 and 6. So the value of y will be 0, 1, 0. And the line for the piecewise function is this should be 3 here. 3 to the value of t is between 3 to 6. Okay, and if t less than 3 is here, and t greater than 6 should be here. Okay, the next one is f of t equals tu of t minus 1. Okay, now we can see that beside near u there is a t here. Okay, and the piecewise function a is 1 and t we put here. This t we put here. Okay, and then multiply t with 0 and t with 1. We have this piecewise function. T multiplied with 0 is 0. T multiplied with 1 is t. And then we can draw the graph. Here, if t greater than 1, y is t. Meaning that when t1, y1, t2, y2, t3, y3. Okay, this is the graph. And when t less than 1, y is 0. Okay, the fourth is f of t equals t minus 1 u of t minus 1, and of course you can see that here a is 1 and near u we have another function. So the piecewise function is, okay, a is 1 here and here t minus 1 we put here t minus 1. Okay, so we multiply t minus 1 multiply 0, t minus 1 multiply with 1, we will have this piecewise function. Okay, so these are the graph when t greater than 1, y is 0 here. When, let's say, t2, y1, t3, y2, t4, y3. So these are the line. Okay, and if t less than 1 is 0, this line. Okay, now we continue on 3.3.2 Laplace transform for unit step function. Laplace transform u of t minus a is exponent negative st multiplied with 1, and we integrate from a to infinity. If we do the integration, we integrate negative e negative st, we have e negative st over negative s, then we integrate from a until infinity. Okay, here I bring negative s outside and then I multiply I replace t here with infinity and t here with a. So here we can see that I believe all of you aware that when we have exponent, negative infinity equals to 0. So 0 minus e negative as multiply with negative here, it will be positive. So I have 1 over s e negative as. Look at example 3.3.2. Find Laplace transform f of t if f of t equals u of t minus 3 minus u t minus 6. Now, okay, we put Laplace transform here. We put the notation here, and then we multiply Laplace transform. We do the transform here, and another one is here. Then we compare with the table 3.3. Okay, now we can look at this property with the first Laplace transform, which is I'm sorry, not the third property, but refer to this property. Okay, here the a is 3 and for the second one the a is 6. Therefore, the Laplace transform is 1 over s e negative 3s minus 1 over s e negative 6s. We apply this property where our a is 3 and another one is 6.